Hello class. I know you missed me already. I'm going to begin by teaching factoring GCF. This is Wednesday's assignment for Algebra 1. I'm going to apologize in advance because I'm sure my kids are going to talk. Gonna have a little boy running in here saying mommy or daddy. So just listen attentively. GCF stands for greatest common factor. And so I'm going to go through the steps of basic greatest common factors, and then you'll see how we're going to look at it in algebra. First one says list 3 prime numbers. So pick 3 prime numbers. I'm sure you pick the first 3 prime numbers, which are 2, 3, and 5. What is a prime number? A prime number is a number that's only factors a 1 in itself. Are 1 and itself. What does that mean? Something like 2, you can only get 2 by saying 2 times 1. Or 3, you can only get 3 times 1, only 1 in itself. The first step says, what are the prime factors of 60? So the way that we're going to do that is we're going to draw a little factor tree. So the number 60, I'm going to do an upside down tea cake. And we're going to find the prime factor. So prime factors are 2. And I put the 2 on the outside. My prime number is going to go outside. And 2 times 30 gives me 60. 30 can keep going lower. So then we know 2 times 15. So I'm putting my prime numbers outside. 15 can break into 3 and 5. And that's as low as we can go. So the prime factors are 2 times 2 times 3 times 5. All those numbers that you see right there on the outside. Got it? Next one, what are the prime factors of 90? We could break 90 into 2 times 45. Then 45 can break into 5 times 9. And 9 can break into 3 times 3. And so that's as far as we can go. So the prime factors are all those numbers right here on the outside. So that's 2. And I'm just put them in order. You don't have to, but I'm put them in order so you can see something next. Times 3 times 3 times 5. So those are the prime factors of 60 and the prime factors of 90. And so which factors do they have in common? If we look, they have a 2 in common. What else? You're right. A 3 in common. And they also have a set of 5s in common. So the common factors are 2 times 3 times 5. Those are the 3 numbers they have in common. And so the greatest common factor, so those are 3 factors they have in common, you get by multiplying all 3 numbers. 2 times 3 times 5, so that means 30 is the greatest common factor. The factor that we could pull out of 60 and 90, the greatest number is 30. Got it? So that's how we did it separately. Now we're going to look at how we did together. So when moving into factoring, we're going to be factoring them together because we know we're going to be looking at polynomials and binomials. So we're going to be looking at them all together. So if we break down with them together, you see we have 60 and 90. So we want to say, okay, what prime factors do both of these numbers have in common? Well, we know easily we could pull a 2 out of both because they're both divisible by 2. So 2 times 30 for the 60, and then 2 times, oh, mine just went blank, 45. Then we're going to break down 30. What common factors do they have in? Well, we know 2, nope, 2 can't go into both. 5 or 5, so I'm going to say 5. They're both divisible by 5. 30 divided by 5, it means 6. 45 divided by 5 is 9. Now I have 6 and 9. I could keep going even lower. They both have a 3 in common. Take 3 out of 2. 6 divided by 3 is 2. 9 divided by 3 is 3. And can we go any further? No, we're down to prime numbers. So the GCF, the numbers that both of them have in common, is going to be what's on the outside. Not these 2 numbers down here, because that's just the leftovers. They don't have those 2 in common. And so that's another way. So here we looked at them separately. We broke down 60 and 90. And then down here we're looking at them together. What do they have in common together? And so that's 2 times 3 times 5, which is 30. Got it? Okay, so now we're getting ready to look at greatest common factor with variables. we know we've looked at algebra tiles before already, right? And so I'll zoom in a little bit more. There we go. So we looked at GCF. I mean, we've looked at algebra tiles. So now we're going to look at algebra tiles and greatest common factor. But we're going to look at it in tiles, and we've done this where we know this is x squared. Factors of x squared are x and x. To get the x bar, we know we multiply x times 1, x times 1 again, and x times 1 again, right? So we've done that on past lessons. Now we're looking at the greatest common factor. Looking at the left and the top, what do they have in common? You said it. That's right. Their GCF is x. They have an x in common. So that's the GCF of x squared plus 3x. If you need a pause to understand and absorb it, then do so. If not, we're going to move along. Now we're going to look at it in terms of using like the little upside down cake, which is the same concept where we look at x squared and 3x the same way we did 60 and 90 above. What do both of those terms have in common? We could pull out an x. And so what's x squared divided by x? X. And then 3x divided by x means we could pull out a positive 3. Draw upside down cake. Is there anything those two have in common? No. One's a variable, one's a number. So there's our answer. The GCF is x. So it's the same thing we did in the previous example with 60 and 90, except we're looking at common variables. Got it? If you want to pause right here and try the next one on your own, you can. If not, I'm going to continue to work. So here we have x squared. We know x times x. To get negative x, we have to multiply by -1 and -1. What do they have in common? You should have got x for the GCF. Same here, looking at both terms together. What do they have in common? I could pull an x out, and that's going to leave us with x minus 2. And there it is. Got it? Okay, now we're in the back. So now we're going to be looking at some more GCFs, just to kind of get a little bit of practice. If you can't see the top, it's really light. You should look on your paper. That actually says 2x squared plus 8x, I think. If it don't say it, make it say it. Okay, so first thing, now we have coefficients in there. So we're going to see what coefficient do they have in common. Let's pull out our prime factors for coefficients. We could pull out a 2. Can't we? They both have a 2 in common. So if we divide 2 divided by 2, that means we're just going to be left with x squared. If we take 8x and divide by 2, that's going to leave us with 4x. So then look at those two. Do they have any more coefficients in common? We could pull out a 1, but if we pull out 1, nothing's going to happen. So that's nothing. We pulled out all the coefficients. So now look at both terms. Do they have a variable in common? Yes. They have an x we could pull out. And that leaves us with x plus 4. Then we look at it. Anything else? No, it's just a variable and a number. So our GCF is 2x. Got that? Okay, let's look at some more. So I'm not going to do all these. I'm just going to work through some of them. If you want to pause to try to do it on your own, you can, and then press play. So the next one we have 3x squared plus 6x. I like to start with coefficients, so they both have a 3 in common that we could pull out. We divide it, we're left with just x squared. 6x divided by 3, we're left with 2x, and that's all the coefficients we could pull out. They also have an x in common, so then we're left with x, and 2x divided by x, we're left with a positive 2. Look at the next set. Anything else? No, that's as far as we can go, so your GCF is 3x. Everybody got that? Okay, next we have a 2, number 2. Do they have a coefficient in common? Yes, they have a coefficient in common. We could pull out a 5. So when we pull out a 5, we're left with a squared b minus 2a squared b squared. Now we notice it's not just one variable, it's multiple. So there are two things you could do with this. If you think you can't catch it, I'll do both ways. You could pull out just an a by itself, and then that'll leave you with 1a and a b, and then that'll leave you with 2 and 1a and b squared, right? But then you look at both of them, they still have an a in common, so you can pull out another a, and that'll leave you a b minus 2b squared. Got it? Or if you wanted to, and I'll rewrite that, let's say if I rewrite that first step again, some of you might want to pull it out by itself, or some of you might be able to look at it and say, oh, they have an a squared in common, and so you could pull the a squared all out at once, and so that will leave you with 5b minus 10b squared. So you could do it either way. Pull out the a's separately, and then when you bring them together, it'd be 5a squared, or you could just bring the 5a squared out together. Got it? Now, oh, I shouldn't have had that 5 right there. Sorry. I'm just messing up. This should have been b minus 2b squared. Okay, now we're still not done, so I was just showing you how to pull out the a's separate, how to put them together. Now, if we kept going, both of these terms have a b in common, right? So we could pull out a GCF of b. And b divided by b, that's going to leave us with 1. And then if we pull a b out of this one, that leaves us with 2b, right? Hold on, pause. Scratch. So that's what I get for trying to do 2 steps in one. Okay, so yeah, we could do it like that, but I messed up here. So our original, see, there goes my crazy son. We have this. So if we pull out a 5, that will leave us with a squared b minus 2a squared b squared. And then like I was saying previously, we could take out a squared, and that will leave us with b minus 2b squared. Then we see they both have a b in common, so we could pull out a b, and then that will leave us with what? B divided by b. You can't just leave it blank, because then you have blank minus 2b squared. You have to put a 1. So b divided by b, of course that'd be b to the 0, so it'd be 1 minus 2, and we have b squared. We take out 1b, and we'll be left with a 1b right there. There's nothing that 1 and negative 2b have in common, so when you look on the outside, you should have got 5a squared b. Everybody got it? All right. Look at number 3. You notice it's just one term. Whenever we have one term, do you remember what that's called? Well, there's no GCF because you have nothing to compare it to. That is just a prime number. One in itself. It's just 6x squared y. Got it? Everybody see why it's prime? Because it's just one term. Look at the next one, number 4. Coefficients. So now, hopefully, you should. Okay, so here you can pull out prime factors if you want. Like, what do they have in common? A 3, but it will take a little longer. So by now, hopefully, you should be able to kind of pick up on if they have any higher numbers in common. Like, let's see what else they have in common. My mind just went blank. Okay, let me start with 3 because I can't even think. Everybody's talking right now. Sorry. Both of them divisible by 3. So 81 divided by 3 is 27x, and 48 divided by 3 is 16xy. Is there a number that can go into both of those? I think that's as low as it can go. 27, 16 is 1 and 16. No, 16 go 27, 4 and 4. 2 and 2, I mean 2 and 8, no 2 can't go 8. Okay, so yeah, okay. So then they also have an x in common, so we pulled it out, we're left with 27. Pull an x out of there, and we're left with 16y. Well, that's as far as we can go. So this GCF is 3x. Everybody got it? Okay. I'll do one more from this top part. Let's see, which one should I do? Let's do number 8. So 8, we're bringing in 3 terms. Well, you know what? No, let's do 6. Let's look at it when we have 2 variables. So with 6, we can look and see what number do they both have in common first, a coefficient. And a coefficient that they both have in common, we could pull out a 17. I bet you some of y'all didn't notice that one. 34 divided by 17 is actually 2. X to the 4th y cubed. 17 divided by 17 is -1. X squared y to the 5th. Look at both of those terms. They have an x in common. This one has 4 x's, x to the 4th. That one has 2. So the easiest thing was just pull out the smallest one. So we know they at least have a minimum of 2 x's in common, right? And so that leaves us with 2x squared. Because remember, when you're dividing 4 divided by 2, you're really subtracting exponents. And so then we have y cubed minus, and we don't really have to write that one, x squared and x squared cancel, and we're left with y to the 5th. Then we could pull out the y's they have in common. That says y cubed, y to the 5th. The smallest one would be 3 y's they have in common, and that would leave us with 2x squared minus y squared. Anything else those two terms have in common? Nope, that's 2 and some x's. That's just y's. Nothing in common, so the GCF is 17x squared y cubed. Got it? Okay, number 8. Looking at that one, we have 3 terms. Some of you might have thought, hey, I could just pull a 3 out of this. But you can't pull a 3 out of here because 3 comes out of the first and the second term, but 3 doesn't come out of the third term. So it has to be in common with all of the terms. So there's no coefficient that can go into all 3 terms. There is one variable, and they all have an x in common. Pull the x out, we're left with 3x squared plus 6x minus 1. Why do we have to put that 1? Because if you don't, then if you were to go backwards, you wouldn't know that it was 3 terms. So you have to put that 1 so that if you went backwards, you would know x times 1. It originally was a negative x right there. That's as far as we can go because there's nothing that can go into all 3 terms, so the GCF is just x. All right, I'm going to do a few of these down here at the bottom. We look at something like, let's do 16. What coefficient can we pull out of them? You're right. Hopefully you said 2. Pull a 2 out, we're left with x squared y minus xy squared plus 2xy. Everybody got that? Then they have an x in common. It's 2 x's and x, so we can only pull 1 out that they all have in common. That leaves us xy minus y squared plus 2y. And then I'll just kind of drag this on up here. And we can also pull a y out, and that will leave us with x minus y plus 2. There's nothing they all have in common, so the GCF here is 2xy. Got it? And I'll do one last one. Let's do, let's see, let's pick a good one. Let's do 24 because it has 3 terms. Okay, so what coefficient do they all have in common? We can pull out a 3. And that'll leave us with a cubed b squared c minus 3a squared b cubed c squared plus 5 a b to the 4th c cubed. Ooh, it's a lot. Let me zoom in case y'all can't see. Hope you can see better there. That's all the coefficients all 3 terms have in common. So then we see they have a bunch of a's. That one has a cubed, a squared, a. So we only have in common 1a because the smallest one here is just 1. So we could pull 1a out. And that'll leave us with a squared, b squared, c minus 3. There's only 1a left. B cubed, c squared comes down. 5, we take that a out because we pulled it out as a GCF. B to the 4th, c cubed. Then we look, they also have b's in common, b to the 4th, b cubed, b squared. So the smallest one that we could factor out is b squared. And I'll kind of bring this up here. And so that's going to leave us with what? a squared c minus